Question 1 is a ratio recipe question. You've been given the ingredients for 16 gingerbread man and Hamish wants to make 24. Now 24 is 8 more than this recipe makes, and 8 is obviously half of this recipe. So the quickest way to do this is to find half of each of these ingredients and add them on. So half of 180 is 90 grams, half of 40 is 20, half of 110 is 55, and half of 30 is 15. And then you just add these on. So your answers should have come out as 270, 60, 165 and 45. Question 2 is a scatter graph. If you have a general trend going upwards and out of your graph, the correlation is positive. And with the second part of the question, you're asked to estimate the arm length of a student who has a certain height. Now to do this question's worth 2 marks. You need to first draw a line of best fit. This needs to follow the general trend of the things that are on there, about half of the crosses on either side. So something like that. And once you have that drawn, you look at the height, which was 148, and you draw a reading line up. Now make sure you take note of the scale. In this case, each little square is worth 1, and then read from it. Now if you've drawn a line of best fit, even if your reading is then wrong, you will score half marks. And if you don't draw the line of best fit and your answer isn't within the range, they won't accept it. Now my answer reads off as 83. I think they accepted anything between 82 and 84. But make sure you draw the line of best fit and the reading lines on there to maximise your marks. Okay, question 3 was answered quite badly, and I think it's because you don't know how electricity bills work. So this was the reading when he last paid a bill, and this is his new reading. So the first thing you need to do is work out how much electricity he has used between, and you do that by subtracting 7,095 from 7,155. And your answer is 60. So he's used 60 units. Each unit costs 15 pence, so you need to do 60 times 15, which you can do by doing 6 times 15, which is 90, and adding the 0. Now this answer is obviously in pence. You needed to indicate what your answer was in, so 900 pence would have got you the full marks, or if you want you can divide that by 100 and give your answer in pounds as £9. Question 4 was about a questionnaire. Lots of you assume this was a data collection sheet question. It wasn't. So in devising a question, the question needs to be relevant to how much time people spend reading books, and it needs to give options, not be in a tally table. So a suitable question would be something like, how much time do you spend reading books? And you need to give a time period, so I'm going to say per week. And remember, someone came up with this to the nearest hour because it makes your options really easy. So we're going to have 0, 1 to 2, 3 to 4, more than 4. Officially you need at least 3 different option responses, so you don't need to give 4, but as long as there's at least 3 there. Question 5 is an estimating question. Edexcel specifically defined how they want you to estimate, and they want you to round each of these numbers to one significant figure and then perform the calculation. So your first mark comes from actually rounding those. So to one significant figure, this becomes 30 times 10 divided by 0.5. Okay, this in turn becomes 300 divided by 0.5. And remember, if you're asking how many halves there are in 300, your answer is going to be double. So your answer becomes 600. Okay, if you want to see that with a fraction, if you did 300 divided by a half, you leave it, change it, flip it, and you can see where that 600 comes from. Question 6 asks you to describe a single transformation. So if we look at this shape, you can see it's changed size and therefore is an enlargement. So your first mark comes from that. Now the question is worth 3 marks, which means there's 2 other things you need to say. For an enlargement, you need to give the scale factor of the enlargement, so what it's been multiplied by to make it larger. And make sure you're going in the right direction, so we're moving from P to Q, not the other way around. And you also need to give the centre. So if you look at the side lengths, the side length of P is 2 and on Q it's 5, which means that that 2 has been times by 2.5. So scale factor is 2.5. And to find the centre of enlargement, you need to join up a couple of lines, or a couple of points. So I'm joining up that centre point there, and I'm joining up these there, and you can do the third point if you want to, and where they meet will be your centre. So this one you can write centre O, because it's given as O, or you could write it as the coordinate point 0, 0. Question 7, it's really useful if you were able to identify the shape at the beginning. It is a trapezium because it has one pair of parallel lines. And if you look at your formula sheet, you can see that the area of the trapezium is found by doing half times A plus B, they're your parallel sides, times the perpendicular height. So I'm just going to write the formula on here, half A plus B times the height, so that I can then use it. Now, my A value is going to be 12 and my B value will be 18, which gives me 30. So I'm going to have a half times 30 times 9. And obviously you could do 30 times 9 and then halve it, whichever you find easiest. So let's calculate that quickly. 3 9s are 27, so that's going to be 270, and then I need to halve that, which gives me an area of the lawn of 135 metres squared. Now, each bag of grass seed covers 20 metres, so I need to divide 135 by 20. Okay, if it's a bit of a messy division, this one, because you're going to have to go straight into that. But if you just kind of add up in 20s, so you go 20, 40, 60, 80, 100, 120, 140. So to have enough, you're going to need to buy 1, 2, 3, 4, 5, 6, 7 bags. Some of you may have worked this out exactly and then done a multiplication, so you may have worked out it was 6.75 bags. Obviously in the real world you would have to buy the whole bag and you just have some left over for next time or a friend. So now I know that we're going to need 7 bags. Each bag costs £4.99. The quickest way to do this is 7 lots of 5, which is going to give me £35. And then I need to subtract the 7 pence, which is the penny, off of a fiver each time. So if I minus 7 pence from that, I get £34.93. And that is the smallest amount of money it's going to cost him to grass seed that lawn. Question 8 is on probability. Now it says that the number of white counters in the bag is the same as the number of black counters. So the probability here is going to be equal. We know that red and blue are 0.2 and 0.5. So if I add those, I get 0.7. And then of course that what's left over is going to be shared between these. So 1 minus 0.7 is 0.3, and if I divide 0.3 by 2 I get 0.15. So the probability of Tanya taking a white counter is 0.15. And if I put that into the table, you'll be able to see that that probability still adds up to 1 in total. The second part of the question tells you that there's 240 counters in the bag and you need to work out the number of red counters. So the first thing to do is to find out the probability of choosing red, which from the table is 0.2. And then we are going to multiply 240 by 0.2. Okay, if I times this by 2, so 2 times 240 would be 480, and then I need to divide that by 10 because I'd obviously times that by 10 to double it. So my answer is 48. Question 9 is volume. It asks you to find the volume of the prism. Do read the question carefully. Some of you found the surface area of this prism. So on the formula sheet at the front of the page, you are told that the volume of a prism is the area of the cross section times its length. So back on this shape, I need to find the area of this cross section and times it by the length, which is 10. So this shape is made up of 2 rectangles. You could either divide them here or down here, doesn't really matter which you choose. And I'm going to do a quick sketch of it so that you can see how I've divided it up. So I think I'm going to divide it here. That means that this rectangle is going to be the result of 4 times 7, which is 28. And this one isn't 2 times 9 because I'm only multiplying this part of it. I've already used that 4. So if that was 4, this bit here must be 5 so that the length adds up in total to 9. So 2 times 5 is 10. And so my total cross section is going to be 28 plus 10, which is 38 centimetres squared. Then to finish this question, I just need to times it by the length, which is 38 times 10, which is 380 centimetres cubed. They gave you the units on this question, so there were no marks for them. Question 10 gives you a map with 2 locations on it and tells you that a company wants to build a warehouse between these 2 towns. Needs to be less than 30 kilometres from Burford and less than 50 kilometres from Hightown, and you need to shade the region. Now this is a clue that this is going to be an area and not just a single point. Any point that is going to be less than 30 kilometres from there needs to be anything, and it would form a circle around the point. 1 centimetre represents 10 kilometres, so you need to use a compass open at 3 centimetres, place that on Burford and draw a circle or some arcs. Doesn't have to be completed, but basically anything within that would be where the company could build the warehouse. Because Hightown, it can be less than 50 kilometres, we're going to open the compass to 5 centimetres, like so. Put the compass on Hightown and draw that. So it's sort of irrelevant anything on this side because you can now see that region's clearly identified. It says shade the region, so make sure you do. Doesn't have to be beautifully done, it just needs to clearly indicate the region where they can build their warehouse. Question 11, the first part you just need to expand the bracket, which means you're going to do 4 times 3x, which is 12x, and 4 times 5, which is plus 20. So your answer is 12x plus 20. The question below is very similar, but you need to do this in 2 separate parts. So first of all, you need to expand 2x minus 4. 2 times x is 2x, and 2 times minus 4 is minus 8. And then we're going to add to that 3 times x, which is 3x, and 3 times 5, which is 15. This question was worth 2 marks, so doing that expansion correctly at the beginning earns you the first one. but it does say simplify, which means we need to get all of our x's together and all of our numbers together. So first of all, 2x plus 3x equals 5x, and then we've got minus 8 plus 15, or you might want to deal with it as 15 minus 8. 15 minus 8 is 7, so our answer is 5x plus 7. The last part of this is a pair of double brackets. You can do this by multiplying each bit in turn, but if you want to make sure you never drop any marks, use the grid method to do it. I'm going to put the first bracket on the left, which is going to be x and 4, and the second bracket at the top, and then I'm going to multiply them into those grids. So x times x is x squared, x times 6 is 6x, 4 times x is 4x, and 4 times 6 is 24. If you do it like this, it ensures you always get at least one of the marks. Your other mark comes from simplifying this. So I've got nothing to go with my x squared. 4x plus 6x is 10x, and then I'm going to add the 24, giving me the answer of x squared plus 10x plus 24. Okay, question 12 is ultimately an area problem, and we have a square here with a circle in it. Now, if we wanted to find the area of all 4 of these corners, it would be the result of the area of the square subtracting the circle. And what we're actually going to do is find that but just one of those corners. So we're going to divide our final answer by 4. So the first thing we need to do is work out the area, oh, I can't spell it, area of square, which is going to be 12 times 12, which is 144. Then I'm going to work out the area of the circle, and because this is a non-calculator question, they're telling you to leave your answer in terms of pi, so you don't need to times anything by 3.14. So the area of the circle is, as we know, pi r squared. And r squared is 6, so it's going to be pi times 6 squared, which is going to give us 36 pi. Now, if we were calculating this to work out the areas of all of those shaded parts, we would at that point take the area of the square and subtract the area of the circle, which would be 144 minus 36 pi. Because we only want one of these corners, I'm going to divide that answer by 4. Okay, so if I divide 144 by 4, half of 144 is 72, halve it again is 36, and 36 divided by 4 is 9, so your answer is going to be 36 minus 9 pi. Question 13 was about ratio, and there were 2 different ways that you could have done this question, so I'm going to show you both of them. What was really important was the fact that Talil wants to make 180 kilograms of concrete mix. So you could have done a normal sharing in a ratio. The ratio here adds up to 9. So you could have done 180 divided by 9 equals 20. And then when you share that out in this ratio, you would have had 20, 60, and then 5 times 20 is 100. That's what you need to make 180 kilograms of concrete mix, but he's only got 15 grams of cement, so he doesn't have enough. The alternative to that method is to look at the fact he's got 15 and put that into this ratio, multiplying each of these numbers by 15 and seeing if it makes 180. So if that was the case, we would have had 15 kilograms of cement, we would have had 45 kilograms of sand and 75 kilograms of gravel. If I add up 15, 45 and 75, I actually get 135 kilograms, which is not 180 kilograms, and therefore he doesn't have enough. Question 14 is about bearings. You could have drawn a diagram, it's up to you, but basically we've got the bearing of a ship from a lighthouse. Now that means that your start point is where the lighthouse is. I'm not very good at drawing a lighthouse, but I don't know, it looks like a Dalek. Anyway, that's where our lighthouse is. And the bearing of the ship from that lighthouse is 50 degrees. Now bearings are always measured from north. And so as a rough estimate, lost my protractor. Here it is. If you wanted to draw the diagram, it would look like this. So here's the lighthouse. This is the bearing. We don't know how far away it is. And if there was a north line there. This is where the ship is. And here we go, that's my very good picture of a ship. So they're asking you what the bearing of the lighthouse is from the ship. So that would mean that at the ship you would start at north and measure in a clockwise direction to get your bearing. So the bearing is this angle here. As I said, you don't need to draw this diagram accurately, but you could have done, and you could have measured the angle. Now you have two choices for how to work this out. You could use interior angles so that you know that this angle and this angle add to 180 and then subtract that from 360, or you could use the fact that these are corresponding angles and just add that 180 degrees there, which is probably the quickest way to do it. So we know this angle in here would be 50 and this angle here would be 180, and if you add the two together you get the bearing of 230 degrees. Question 15 was done really well. So when we are dividing these, because this would effectively be m times m times m times m divided by m times m times m, 3 of these cancel out 3 of those, so it's effectively 5 minus 3, which is 2, or m squared. Down here we've got the 5 and there's no other number timesing it, so we are going to have 5 times x to the power of 4 times x to the power of 2, which means we add those two powers, and y to the power of 3 times y to the power of, well, there isn't a power there, so when it's not there it's the power of 1, so we need to have 3 plus 1. That will give you an answer of 5 x to the power of 6 y to the power of 4. Question 16 gives you a triangle. All of the side lengths of the triangle are expressed using an algebraic term, and you are told that it totals 56 metres. Now if you did know what these were, you would just add them up, so we're going to do exactly the same. So 3x plus 1 plus 3x plus x minus 1 equals the perimeter, which is 56 metres. I'm going to tidy up this side so it's a bit easier to deal with. So I've got 3x, 3x and another x, which is 7x, and I've got 1 minus 1, which cancel each other out. So 7x equals 56, and therefore x is the result of 56 divided by 7, which is 8. Once I know that x equals 8, I can find out the side lengths of the triangle, put them back in and calculate the area. So if x is 8, the bottom of the triangle here is 3 times 8, which is 24 metres. And at the top here, this is going to be 8 minus 1, so that is going to be 8 metres. So the area of the triangle, not 8 metres, 7 metres. So the area of the triangle is going to be 7 times 24 and then divided by 2. Okay, if you want to, you could halve one of the numbers right at the beginning, so you could just do 7 times 12, but either way, and you might want to do a long multiplication, but 7 times 20 is 140, 7 times 4 is 28, so you've got 168 there, divided by 2, which is 84 metres squared. Okay, this question is about regions and it talks about integer coordinates. An integer is a whole number, positive or negative, including 0. So it's any coordinates that lie within this region. Now, because all of the regions defined are either greater than or less than, none of the points are going to lie on these lines. So they've already drawn the first line, y is greater than x minus 2, and we've got x plus y equals 10. So the line that's missing is x is greater than 3. So we draw a line at x equals 3. So this is where x equals 3, and I'm going to draw a line here. Now by rights, if it can't equal it, it should be a dashed line, and the ones that are there, in theory, should be. And you'll notice that this creates this nice little triangle inside, and quite often with regions, you can just look for the shape that it encloses. So we're going to look at all the coordinate points that are inside there but aren't on the line, which is going to be these ones. And then I'm going to write down those coordinates. So I've got 4, 3, 4, 4, 4, 5, and I've also got 5, 4. So they're the coordinates that are identified by that region. Question 18 is about angles and polygons, and it's really important to note this. This diagram is not accurately drawn. You get all the information you need about the question from the wording. So there's 2 different polygons used in this, one of which is a triangle, and it's a regular one. So the regular triangle is of course equilateral. That instantly gives us an angle fact, because we know that every one of these angles is going to measure 60 degrees. Now, if I look at this angle up here and just kind of recreate it down here, because we know they're both regular polygons, so we know that all the sides and angles are the same. If this angle here is 60 and these 2 angles must be the same, I can find out what they measure by subtracting the 60 from 360 and dividing it by 2, because this will make a full set of angles around a point. So 360 minus 60 is 300, and 300 divided by 2 is 150 degrees. So on the polygon that I'm looking for, tile A, I know it has an interior angle of 150. So let's just draw that. Now, the easiest way to deal with polygons is always to use their exterior angles, because they all share a common fact, that the exterior angle is always 360 divided by the number of sides, and that the exterior and interior angle always adds up to 180. So if this interior angle measures 150, I know that the exterior angle measures 30 degrees. Now, if 360 divided by the number of sides gives me this answer, the exterior angle, then it follows that if I switch that around and do 360 divided by the angle, it's going to tell me the number of sides. So what I'm going to do now is divide 360 by 30. 360 divided by 30, so I can get rid of those 10s straight away, and 36 divided by 3 is 12. Tile A has got 12 sides. The first part of question 19 asks you to draw a box plot, and it looked very straightforward because they gave you the 5 points that you need on a box plot. The shortest and longest times, or the highest and lowest value, the upper and lower quartile, and the median. But what they did quite cruelly is they gave you a really unpleasant scale. So if you look at this, there are 10 squares but only 5 minutes between each. So this, each 2 squares is 1 minute. And if you didn't notice that, your box plot would have been wrong and you'd have lost all the marks. So the shortest time is 18 minutes, so I need to count up 6 squares. That's where my bottom whisker will go. The lower quartile is at 25. The median is at 29, so I need to count 2 squares in. The upper quartile was at 33, so again that's going to look like 6 squares in. And the highest value at 44, which will be 1 square in from the end. You then just needed to make your box and draw the lines out for your whiskers. The second part of the question asks you to compare the boys and girls distributions. To ensure you receive maximum marks, you need to do 2 things. You need to compare one exact value, and I would recommend the median, and you also need to compare a range, and it's probably easier to compare an interquartile range, but you could compare the full range. But definitely one value, one range. If you compare 2 values or both ranges, you won't get the marks. So I'm going to start off by saying the girls' median time is 29 and the boys was 25.5. So girls' median is higher. And then I'm going to compare the interquartile ranges. You can see from the size of it that the boys' interquartile range was larger. Or you could say wider. But that's all you need to say to get your marks. Question 20 needed you to be able to deal with multiplying and dividing by powers of 10. So this is effectively being multiplied by 100, or is going to tell you to move all of your digits 2 places to the left because they're going to get larger. So this number, if I do that, will become 3.8. Now, because this power is negative, it's effectively being divided, and it's being divided by 10,000. So these are all going to move 4 places to the right, which means that this will become 0.38. This question isn't being changed at all, or this number, so it's just going to stay as 380. And the last one is also being divided, but just by 10. So this is going to become 0.038. So you can now see the size of the number and put them in order. Now it tells you to start with the smallest number. If you don't start with the smallest number, you will drop marks. So make sure you're reading the question properly. So my smallest number is this one, which is 0.38 times 10 to the power of minus 1. You could leave it as 0.038. You don't lose marks for that. The next largest is this, 3,800 times 10 to the power of minus 4, followed by 0.038 times 10 to the power of 2, and then 380. Question 21 is a fairly standard cumulative frequency question, and it starts off with asking you to find the cumulative frequency, and I do that by making a running total. So this is going to be 2 plus 9, which is 11, and then 11 plus 23, which is 34, 34 plus 31, which is 65, 65 plus 27, which is going to be 92, and 92 plus 8, which is 100. They told you in the question that these were the speeds of 100 lorries, so do make sure that your cumulative total adds up to what they've told you should be there. Then asked to draw your cumulative frequency diagram. Remember that you plot at the top of the class interval, so my first point is going to be at 20 and then going up to 2. Check your scale. Again, this is going up. You get 5 squares for 10, so each one is worth 2. So for this one at 20, I'm just going to be 1 square up. Then for 11 at 40, I'm going to go just above the 10 line. And at 60, I'm going to go to 34. At 80, I go to 65. And at 100 is 92. And finally, at 120, I'm going up to 100. So that's what the points should look like, and you need to join them up. Now you can either join them using a ruler or a smooth curve, and in this case, because it does go down to 0 on here, I'm going to join it down to the origin. Okay, so there we go, that's drawn in. The last part of the question asks you to use the graph, or it doesn't say use the graph, but it says find an estimate for the number of lorries with a speed of more than 90 kilometres. Now that means you need to go to where speed is 90 kilometres and draw a reading line up to the graph. So at 90, I'm going to draw this reading line. And where it hits the graph, I'm going to read off on this side. Now, this is telling me that 80 of the vehicles travelled at 90 kilometres per hour or less. So if I'm looking for ones that travelled more than that, it's the ones that fit in that part there, of which there are 20. As long as you draw your reading lines onto the graph, they will use what your graph has read off, even if your graph was drawn incorrectly in the first place. So do draw those reading lines, because they ensure against losing marks. Question 23 is a simultaneous equation question, and you all attempted this last week. So we don't have either of the equations having the same x's or y's, and none of them are easily changed. So I'm going to decide to get rid of my x's first. So I'm going to take this 4 up and times the top equation by 4, and take the 3 down and times the bottom equation by 3. So 4 times 3x is 12x, 4 times 2y is 8y, and 4 times 4 is 16. 3 times 4x is 12x, 3 times 5y is 15y, and 3 times 17 is 51. Now I'm going to look at the signs on my x's, because they're the ones that are the same. They're not in there, but if they were, they would both be pluses. And then I sing the song, if the signs are the same, you subtract. So I don't need to sing anymore, because I'm going to subtract this. So the x's will just disappear. But I'm going to have 8y minus 15y, which will give me minus 7y. And on this side, I'm going to have 16 minus 51, which is going to give me minus 35. That means that y will be minus 35 divided by minus 7, which is going to give me the answer of 5. I'm going to write that in at the bottom now. Okay, so we're only halfway through the question, because we need to substitute that 5 in to find x. So if I take the top equation from the original question, which is 3x plus 2y equals 4, so I'm going to do 3x plus 2 times 5 equals 4, which is going to be 3x plus 10 equals 4. Now if I solve this and move the 10 across and subtract it, 3x is going to be 4 minus 10, which is minus 6. X is minus 6 divided by 3, which is minus 2. So your solutions are minus 2 and 5. Okay, this is rather a complicated graphs of straight lines and perpendicular lines question. So we know that this line here between D and A is minus 2x plus 6, and because of that, point D is where it intercepts with the y-axis, so we know that that coordinate is at 6 on the y-axis, which means that the top part of this line is going to be 6 units tall. One of the things that we need to know though is this point, and this point is shared between the line minus 2x plus 6 and the line that goes between P and B. Now they are perpendicular to each other, and we're going to use that fact in a moment. But to find out the point on the x-axis, that's obviously where y equals 0. So we're going to take this and replace that y with 0. So we're going to have minus 2x plus 6 equals 0, and then we're going to solve this equation. So if I move the 6 over, I end up with minus 2x equals minus 6, and x is going to be minus 6 divided by minus 2, which is 3. So this point here is going to be where x equals 3 and obviously y equals 0. So we've identified a point that is shared between these two lines. Now, to finish this question, we need to find the equation of the perpendicular line, because that will tell us where this point is on the y-axis, and then we can work out the difference between the two. So, if it's perpendicular, our gradient is going to be the reciprocal with the sign changed. So if this is -2, this line will be positive, and the reciprocal of 2 is a half. So we know that the equation of this line is going to be y equals half x plus c. And the c is going to be that point on the y-intercept. Now we need to know a point that the two lines share. And that point we've just found. It was here, the 3, 0. So in that, x equals 3 and y equals 0. So I'm going to substitute that into that equation and solve it. So y equals 0 when we have a half times 3 plus c, which means that 0, 3 lots of a half is 1.5 or 1.5 plus c. And for this equation to equal 0, that c there must equal minus 1.5. It means that the equation of that line is going to be y equals half x minus 1.5. And on the graph, that of course tells us that this point here is at 1.5. So 0, 1.5. It also tells us that the distance from O to P is 1.5. So now I just need to add the 6 and the 1.5 together, which will give me the length of PD, which is of course 7.5. Question 24 is rearranging a formula, and you're asked to make t the subject of the formula. So you want to rewrite this so it is t equals something and t doesn't appear in any other side. Now the first thing you'll notice is that this is dividing everything on that side. So the first stage of the working is to multiply both sides by 4 plus t. So on the left hand side we are going to have p times 4 plus t. And on this side, it will just undo that division, leaving us with 3 minus 2t. So we've got no fractions anymore. Then I'm going to expand the bracket on the left-hand side, which is going to give me 4p plus pt. And that's going to equal 3 minus 2t. Now remember, we want to get all the t's together and everything else away. So I'm going to move the 4p across to the other side, where it will become a minus 4p. So that's going to give me pt equals 3 minus 2t minus 4p. So the work was move 4p. But I've still got a t on this side, so I'm now going to move that back over to this side. And it's currently negative, so when it moves across, we will be adding 2t. So that is moving 2t, so I'm going to have pt plus 2t equals 3 minus 4p. So I've now got all the t's on one side of the equation, but they are still mixed up with some other letters. So the way to get rid of that, because they both have t as a factor, is to factorise into a single bracket. So if I factorise here, if I take the t out, t times p will give me pt, and t times 2 would give me 2t. Now this is a multiplication, and the way to undo that multiplication is a division. So I'm now going to divide by p plus 2. On this side it will cancel out the multiplication, leaving me with t, and on the right hand side it will stay underneath, and I have made t the subject of the formula. Question 25 is about similar shapes, and with shapes you have linear scale factors. That's how you get from one length to another. You'll have area scale factors, so how you get from an area to another, and you'll have a volume scale factor. Now these are connected in the same way they would be if you were finding an area or a volume, in that to find an area you square the linear scale factor, and to find a volume you cube it. Now if you look, we've been given lengths, which are our linear scale factor. On shape A it's 4 and on shape it's B, which means that our linear scale factor is just 2. It's been doubled. Now if we're asked to find the volume, our volume scale factor is going to be that cubed. So I take the 2 and I cube it, and 2 times 2 times 2 is 8. It means that if I'm moving from the volume of one shape to another, rather than using a scale factor of 2, I use the 8. So if my volume on shape A is 80, or solid A is 80, I'm going to times that by 8. 8 eighths are 64, and then I add the 0. So the new volume, or the volume of solid B, will be 640 centimetres cubed. The second part of the question tells you about surface area. So if I go back to here, again, I still only know the linear scale factor, but I can find the area scale factor by squaring it. So 2 squared is 4. So our area scale factor is 4. Now this time they're giving me the volume of solid, or the surface area of solid B. So I'm moving from the larger to the smaller. So instead of doing a multiplication, I'm going to do a division. So if the solid B's surface area is 160, I'm going to divide that by the area scale factor, which is 4, which will give me the surface area of solid A of 40 centimetres squared. Question 26 is on surds. To rationalise a denominator, you need to make this number a whole number, so it isn't an irrational number anymore, and you do that by multiplying by a fraction equivalent to 1 that includes that surd. So same rules apply, top times top, which means that the numerator will be 5 root 2, and underneath root 2 times root 2 is 2. My denominator is rationalised. For the second part of the question, you need to expand the brackets and then do the subtraction. So I'm going to use the grid method again. So here I've got 2 and root 3 and 2 and root 3. And on this one, I'll have a grid, I'm going to draw it slightly bigger, 2 and minus root 3 and 2 and minus root 3. So I'm going to fill the grids. 2 2s are 4. Surds work just like algebra, so 2 times root 3 becomes 2 root 3, and this will be 2 root 3, and then root 3 times root 3 is 3. So this expansion is 4 plus 4 lots of root 3 plus 3, which is the same as 7 plus 4 root 3. Down here I'm going to do the same, so 2 times 2 is 4. 2 times minus root 3 becomes minus 2 root 3, so the same here, and minus root 3 times minus root 3 will again give us a positive 3. So we would end up here with 4 minus 4 root 3 plus 3, which is the same as 7 minus 4 root 3. Now back in the original question it asked us to subtract the answer to this one from the answer to that one. So that's what I'm going to do. 7 minus 7 gives me 0, and 4 root 3 minus a negative 4 root 3 means I'm going to add them, so my solution is 8 root 3. This equation here is the equation for a graph of a circle. And because x squared plus y squared equals the radius squared, all I need to do is find the square root of 4, which is 2, and that tells me that the graph will be at the centre of 0 and needs to be 2 wide. So I put the compass on and draw it. and that's the graph of x squared plus y squared equals 4. Question 2 just asks you to draw the cosine graph. The cosine graph starts at 1 and it goes down to -1, and it follows through the full 360 degree cycle. So we're going to start with a point at 0, 1, then at 90, 0, at 180, -1, at 270, 0, and at 360, 1. And the graph kind of looks like this. Okay, the final question was on vectors, and some of you actually had quite a good go at the first part of this question. You're asked to find the vector PB in terms of A and B, and with vectors you can only go along routes you know. So I can't go from here to here directly because I don't know the vector for it. So I'm going to go on a journey from P to B along what I know. So from P to N I've gone the wrong way along a B, so I've gone -B. And from N to A I go another 2B but in the wrong direction, which is -2B, and then to get from A to B I'm going along A in the right direction, so that's a +A. So if I tidy this up, you can do it just like algebra. I end up with -3B plus A, or you could have written it as A minus 3B. After we've done the first part of question 1, it's useful to just add to your diagram that you know this route and that it is -3B plus A, or you can write it as A minus 3B. The next part of the question gives you some other information. So it tells you that B is the midpoint of AC. That means that we know that this vector will be the same as AB because it's halfway along, so it's just going to be A. It also tells us that M is the midpoint of PB. So if you were going half of this distance, you would just halve this, so it would be -1.5B plus half of A. And equally if you did that top part. They then ask us to show that NMC, which is a line that would go from here, are on a straight line. Now for that to be true, our vectors need to be multiples of each other and share that common point M. So we need to do two things. We need to find the vector that collects N with M, so we need to find vector NM, and we also need to find the vector for MC. So that's what we're going to do. Remember, we can only go along routes that we know. So to find MM, I'm going to go from N to P, which is just B, and then I'm going to go from P to M, which is half of -3B plus A. So that's going to be -1.5B plus 0.5A. Okay, so that's what it looks like, and I'm going to tidy that up. So this vector is going to be -0.5B plus 0.5A. I'm then going to find the vector that links M to C. So that is going to be going halfway up PB, which we know is -1.5B plus 0.5A, and then along from B to C, which I know is A. So I'm going to add a whole A. Now if I look at this, when I tidy it up, I get -1.5B plus 1.5A. Now, if you look at these two vectors then, they are multiples of each other. So they're multiples of each other, which means they are at least parallel, going in exactly the same direction. So they're on a straight line if they share a common point. Well, they do share a common point. NM and MC share point M. So if they share point M, they are therefore on a straight line.